All right, now for the free response, make sure you show all your work on the final. So the first question says that the graph below represents the tide in feet at a certain beach X hours. So this is your X after midnight in a particular day. When are the levels decreasing, the water levels? Also, this is what the water is doing. The levels are increasing until this point, and then they are decreasing from here to here, and then they are increasing from here to here, and then they are decreasing, and then again increasing. So the levels are decreasing between what X values? Well, between whatever this X is and this X is. So it looks, the X is the first coordinate, so it will be between 2.6 and what is the X in here? At this point the X is 9.2, and then also between 15.8 and 22.4, which is this one right here. So it's the X value that tells us when the Y value, the tides, are decreasing. Use interval notation to give the range of the function over this 29 period. Remember, the range is all the Y values. So the Y values are ranging from 1.4. You see how these points right here are 1.4 all the way up to 2.6. So in interval notation, this will be 1.4 to 2.6. And I put brackets because at 9.2 is 1.4 and at 22.4 is 1.4. So it includes the end values. Write a sentence explaining what the range represents in the context of the problem. Make sure you use units in your sentence. So the range represents the height of the tides in a day after midnight the tides range from 1.4 feet to 2.6 feet. So that you can think of this as your minimum and this your max. Alright, next question. Consider the graph of a quadratic function shown in the figure. You must use the fact that 0, -4, which is this point right here, is a point on the graph. So for this problem, you need to get the quadratic, right? So, oh no, for this one it says to answer these questions. Is the leading coefficient A positive or negative? Well, since this is going down, the parabola is opening like this, it means the coefficient A is negative. Is the discriminant positive or negative? Well, since it intersects in two spots, that means that it's positive. If it was in just one spot, if it was just touching, it was 0, and if it didn't intersect, it was negative. Use the graph to get the coordinates of the vertex. Well, the vertex is right here, and the x coordinate of the vertex is -3, and the y coordinate is 5. And now the quadratic function, yeah, we do have to find I have the vertex, right? I know that the leading coefficient has to be negative, but I don't know what exactly it is. So the formula is going to be y equals a times x minus h squared plus k. But h is -3 and k is 5. So then this is going to become y equals a times x minus -3 becomes x plus 3, and then plus 5. But now I need to find what a is. So how do I do this? Well, I have to use the fact that 0, -4 is a point. So 0, -4 is a point. This is when x is 0, y is -4. So instead of y, I'm going to put -4. And instead of x, I'm going to put 0. You see how this, now we're going to solve for x. So solving for x, we get -4, for a, I'm sorry, equals a times 9, because 3 squared is 9, plus 5, add -5, so it will be -4 minus 5, it's -9, equals 9a, so a equals -1. Alright, so then the function in vertex form is negative, so it's y equals -x plus 3 squared plus 5, because a is -1. Now to get it in general form, I would just have to calculate what that is. So in general form is y equals -x plus 3 squared is x squared plus 6x plus 9, and then the plus 5. So now I'm going to distribute the negative x squared, -6x, and then I have -9 plus 5 will give me -4. So this is what I would put for the quadratic function in general form. Okay, next. The function c of t represents the number of trucks exported t years after 2000. Use this model to algebraically determine how many trucks did the country export in the year 2000. In the year 2000, I just plug in t equals 6. So this is going to be c of 6, and you get that this is -5,000 times 6 plus 55,000. So -5,000 times 6 plus 55,000, you get 25,000. So in 2006 there were 25,000 trucks exported. Now in what year did the country export in only 11,000 trucks? That means that this equals 11,000. So 11,000 equals -5,000 times t plus 55,000. So now I gotta solve for t, because it says in what year. So I need to solve for t. So to solve for t, I subtract the 55,000, and then I'm gonna divide by -5,000. So I will have 44,000 equals -44,000 equals -5,000 t, and then divide by that, I'll get 88, or 8.8. So rounding up, I would have that it's t equals 2009. 8.8 years after 2000 is almost 2009. All right. Match each function of the following description. So you're given these functions and you need to decide which one has these properties. So a function that has the same y-intercept as this. Well, what is the y-intercept of this? The y-intercept equals 5 times 0 squared plus 5, which is 5. So you're looking at these functions and you need to see which ones have a y-intercept of 5. Well, this one is y equals 5, so we know it's a horizontal line, and its y-intercept is 5. So then this is C right here. A function that is always increasing at a decreasing rate. Well, we did this previously. This is one of the previous questions. We know that this is a function increasing with a decreasing rate. That's a question that we did earlier. So then that's G. A function that is increasing by a constant average rate of change. This means a linear function. So you have to identify that. Which one is a linear function? So maybe this one, y equals mx plus b, but the y-intercept is 7. And if you notice, if I add 10 from negative 13 plus 10, I get negative 7. If I add 10 to negative 3, I get positive 7, and so on. So it's actually, the slope is 10x plus 7. So the constant, the rate of change stays constant, and it's 10. So then E is the answer for that one. A function that is always negative. Well, notice all of these y values are negative. So that's D. A function with domain negative 2, negative infinity, negative 2, union negative 2 to infinity. Well, the domain of this function, remember that x plus 2 cannot be equal 0. So that gives you that the domain is everything but negative 2. All right. A basketball player throws a ball. The height of the ball in inches, t seconds after the moment of release, is given by this. Well, you know, this is a quadratic going like this, right? Because negative 16 is negative. All right. Notice this function is valid only from the moment the ball is released until it hits the ground. Okay, so the x is time in seconds, and the y is height, the height of the ball. So it doesn't make sense for time to be negative, so we need to adjust this to this, and it doesn't make sense for height to be negative. So this is the formula. This is the graph, because time cannot be negative and the height cannot be negative, so I can't go down this way. Okay, how tall is the player, i.e. what is the initial height of the ball? Well, a time equals 0 when you have the player and the ball is in his hand and he throws the ball. So how tall is the player is the height at time equals 0. So if you plug in 0 for t in the function, you will get 80. So the initial height of the ball is 80 feet. When does the ball reach the maximum height? When, it means I gotta find this time right here when the maximum height is reached. Why does it do that? H of 0 is 80. So this is the x coordinate of the vertex. So it's negative b over 2a, but b is 40, so negative 40 over 2 times negative 16. So if you plug that in your calculator, negative 40 1.25 seconds. So after 1.25 seconds, the ball reached its maximum height, and then after that it comes down until it hits the ground here. Now what is the maximum height? Well, I just plug in 1.2725 in the height, so it's the height at t equals 1.25. So if you plug that in your calculator, that's going to be negative 16 times 1.25 squared plus 40 times 1.25 plus 80. So 105. 105 what? Feet. How many seconds have elapsed when the ball hits the ground? That's the x-intercept, so we need to solve in here. So that means the ball hits the ground. It means that the height equals 0. So you'll have 0 equals negative 16t squared plus 40t plus 80. So you just need to solve this. You can solve by using quadratic, or you can factor it. So let's solve it by factoring actually. So I'm gonna factor out at negative 16. I can't factor this. Okay. Maybe an 8, sorry. Let's just use quadratic formula. Negative b plus or minus square root of b squared minus 4ac over 2a. I need more space and this is not cooperating. All right. Alright, so I'm gonna write in here negative b plus or minus square root of b squared minus 4ac over 2a. So it's gonna be negative 40 plus or minus square root of 40 squared minus 4 times a times c over 2 times negative 16. So let's put that in the calculator. It's going to be negative 40, let's do the plus, square root of 40 squared minus 4 times negative 16 times 80. I get out of the radical, close the parentheses, and then I divide by 2 times negative 16, and I get this, negative 1.311. So, and then type it again, and instead of plus square root, I'm going to choose the minus square root. And that will give me 3.81. So negative 1.31 and x equals 3.81. And this is seconds. I'm sorry, xt, not x, but t. But it doesn't make sense to have negative 1.311. Basically, this is this one right here, but it doesn't make sense. So the one that I'm interested in is this one, and this is 3.81 seconds. Okay. After 3.81 seconds, the ball hits the ground. Use the information from the previous parts and sketch a graph of the height. Make sure you label your axis and draw the graph with its arrow. Okay, so what we're doing in here is basically putting all this information in the graph. So we're saying that the x-intercept is 80 feet. That was part A. And then that the vertex happened after 1.25 seconds and it's 105 feet. So the vertex right here is 1.25 seconds and 105 feet. And then that this x-intercept right here is 3.18 seconds. So this is t in seconds and this is height in feet.